Okay, hi there, everybody. This is the review of the first review for the Math 3 final exam. Okay, in the first problem, we've got a right triangle problem here. There's the ladder is 18 feet. The bottom of the ladder is 10 feet away from the wall, and you're supposed to find the height of the wall. That's a simple, straightforward use of the Pythagorean theorem. Just make sure that your ladder is the hypotenuse, and so your equation is set up like this: 10 squared plus the height, whatever that is, squared equals 18 squared. You work that out, you'll get the square root of 224, which is just a little bit under 15. To find the angle down there, you will have to use the inverse cosine or tangent or sine, but using the sine or the tangent function uses this measurement right here, which we've just kind of rounded off. So we can be more accurate by using these two numbers here, which would mean inverse cosine function. And you just take the inverse cosine of the adjacent over hypotenuse, and you get 56 degrees. All right, so with the next problems there, you're converting each one of those angles from degrees into radians. Here are the answers, okay? Not much to explain in terms of the process. Just make sure you're reducing the fractions as much as you can, okay? So there you go. So there's all the degree measurements for those radian angles. All the way out here, this is 100 degrees here for this one, okay? So the next problem uses the equation form for a sine function here. So there's A, that's your amplitude. This thing at the other end is your vertical shift. And this thing right in here, this k value, we get that from taking 2 pi divided by the period. So you look at the graph and you can tell all of those things. You can see that if you imagine where the line is that goes right through the middle of the graph, it'd be right there at y equals 4. And the graph goes all the way up here to 12 and all the way down to -4. So you can tell that that's true because it goes the same amount up as it does go down below that line. So there's your midline, and that is your vertical shift, okay? Y equals 4. The amplitude is this distance right here from that midline to the top or to the bottom, or another way to calculate it is to take the highest point minus the lowest point and then divide by 2. So that's from 12 down to -4 is 16. 16 divided by 2 is 8. So, and that's the same distance right here, it's 8. So the amplitude is 8. The period is the distance between where the graph starts to repeat itself. So if it starts right there, goes up, comes back, and starts to repeat itself right there, which is a distance of pi radians. So the period is pi. The k value is what shows up in the equation right here. We do not show the period in the equation. Instead, we show this k value, and that's always the same thing, 2 pi divided by the period. So 2 pi divided by pi is just 2. So there's your final equation right there, your amplitude, your k value, and the vertical shift. All right, the next 3 problems here. This is pretty straightforward, multiplying a couple of binomials together. Don't forget your order of operations. Don't forget to combine your like terms. Okay, pretty easy review idea right there. Probably won't cause you too much trouble. This is pretty basic stuff for you guys. Okay? So just checking your work. If you have questions, post them in the forum, of course. So let me look at the back side of the page here. So we went over these in class today. These are all polynomial curves. We've got the roots sort of revealed by these factors in each one of these equations. So a factor of x minus 2 means there's a root at positive 2. Or a factor at x plus 3 means that there's a root at -3. And anytime you have a factor that is squared, like this one, that means that that 0, or that root, is a place where the graph just bounces off the graph, like that, okay? So we've got these graphs right here. Oh, there we go. And here's another double root, like here for this x minus 2 factor squared. You do not have to worry about how high or how low these graphs go. That won't be part of any of the work that you do on this next test, but I do need you to know which direction the things go. This one's going down to the right because there's a negative sign in the equation. The other two are positive, and they both go up to the right, okay? This is an even degree function, so both ends are going up. This is an odd degree function, so only one end is going up. They go in opposite directions. Okay, so take a look at those. You can check your work there. The next couple of things are factoring. So factoring a couple of quadratics and canceling out the common factors. So the x plus 3's cancel out, and you end up with x minus 1 over x minus 2. Please note that you cannot simplify this anymore. You can't just cancel out the x's. That doesn't work. So that's the final answer for there. This one, when you factor it out, the x plus 2's cancel out, and you have x plus 3 over x plus 2. Okay? Next group of problems is about adding fractions. Okay, and so you must have a common denominator to add fractions together, or subtract fractions. Oh, I don't have one of those. So 9 over x, 7 over 8. The common denominator is x times 8, or 8x. And so this one has to be multiplying by 8 over 8. This one has to be multiplying by x over x. So you got 9 times 8, that's 72. 7x, okay? And so once you have the same denominator, you just add or combine the numerators together, and the denominator stays as is. So 72 plus 7x here. This one started off with the common denominator, so you just combine the numerators together. 12 minus x plus 2x is 12 plus x. Over here, we had to do a little bit more work. The top and the bottom here have to multiply by x plus 3. And over here, this other fraction, the top and the bottom have to multiply by x. Okay? So now we have the denominators the same, and we combine the numerators. X plus 3 plus x, that's 2x plus 3 over x times x plus 3. Okay, last little section here about logarithms. Okay, we finished up class today with these, but in case you had questions, here they are. You're splitting this, each of these logarithms up and expanding them as much as possible. So that's a product, 7 times x to the 5th. So that would be a sum of 2 logs. But that second one of x to the 5th, you can break that down a little bit more by taking the exponent and using it as a coefficient on the log. So log 7 plus 5 times log x. Okay, don't forget that. Here is another kind of sneaky case of that, because this one's a quotient, so that means you're going to be subtracting. So there's your numerator, just a, and the denominator is the square root of b, which can also be written as b to the 1/2. So then we have that same situation that we had over there. We have the exponent of 1/2 kind of wrapping around, becoming a coefficient for the log, natural log of b. Okay? This one over here has another special little circumstance because it's got an x plus 3 that's bracketed there with the parentheses. That cannot be split up. So that has to stay together for the whole expansion. And on the bottom of the fraction we have 2x. So natural log of 2x can be split up. The natural log of 2 plus natural log of x. But it's minus that whole thing. So minus that sum, you could write it either way. These are both perfectly correct. There's no difference really. Okay? Last couple problems here. You're evaluating some logs. 2 to the what power equals 8. That'd be 2 to the 3rd. Over here, 3 to the what power equals 1/3. You just kind of have to know some of your basic powers of basic bases here. So 3 to the negative 1st equals 1/3. That's a reciprocal. 3 to the 4th is 81. So that would be, that log equals 4. Over here, anything to the 0 power equals 1, right? So it doesn't matter what that base is. Log of anything, or log any base of 1 always equals 0, because the only way you get 1 from raising a number to a power is if that power is 0. All right, last couple problems here then. These are just like these, except you're going in the other direction. Here you're combining all these things together into a single log. Make sure that your final answer here only has one logarithm, okay? So we've got that 2 could be an exponent of the a squared and the b are multiplied together because we're adding the logs, and then since we're subtracting this, 3 can be an exponent of c. That goes on the bottom of the fraction. All right, so a squared b over c to the 3rd. And the last one here, again, there's the x plus 1 bracketed, so it cannot be split up or combined with anything. You can raise it to this power here, though, x plus 1 squared, and then this 1/2 log z. Oh, it should be a z, not an x. Sorry about that. Let's change that. There we go. Z. Okay? So there you go. That's the final answer there. Okay. If you have any questions, be sure to post them in the forum. Bye.